Welcome to my YouTube channel, A Brainery of Civil.
Today I am going to solve the fourth assignment of matrix methods of structural analysis. Okay, so you can see the first question. What is the physical meaning of a stiffness matrix to be singular? So generally in the stiffness matrix the unknowns are displacements. The matrix is singular means the determinant of a matrix is 0. When the determinant of a matrix is 0, when two rows or two columns of a matrix are equal. When two rows of a matrix are equal, so it means the unconstrained degrees of freedom. There is no constrainment of degrees of freedom in the particular given structure. So then the determinant of the matrix will become 0. So option C for question number 1. Next, he has given a truss. Calculate degree of static indeterminacy and kinematic indeterminacy. Degree of static indeterminacy is equal to m plus r minus 2j. So the number of members are 1, 2, 3, 4, 5. So m is equal to 5 and number of reactions at A is equal to 2. That is at hinged support 2 reactions, at roller support 1 reaction, at roller support 1 reaction. Total 4 number of reactions. Minus 2 into the number of joints are A, C, B, D. So it is 4 number of joints. It is 9 minus 8 is equal to 1. Degree of static indeterminacy is 1. So option B or C will become the answer. Now degree of kinematic indeterminacy is equal to 2j minus r. So that is number of joints into 2 minus number of reactions. 2, number of joints are 4 and the number of reactions are 4. So that is 8 minus 4 is equal to 4. So the 1 and 4 are the correct answer. Option B for question number 2. Now coming to determine the transformation matrix for AD member. So what is, first of all, we will go AD member is this one. So that is, this is an inclined member. So this is A and this is D. The initial load is A. So you can see here it is A. And the length he has given it is 5 meters. It will become, so it is 3 and it is 4. So here theta will become 36.87. Okay, so now transformation matrix for AD will become lambda x, lambda y, 0, 0, 0, 0, lambda x, lambda y. This is a transformation matrix. Here lambda x is equal to cos theta x. It will become 4 by 5.8. Lambda y is equal to cos theta y. It will become 3 by 5. It is 0.6. So now you will get it is 0.8, 0.6, 0, 0, 0, 0, 0.8, 0.6. Clear? So the answer TAD will be this one answer. So option B for question number 3. Next question. Determine the stiffness matrix for the member AD considering the degree of freedom as 1, 2, 3, 4. So you already calculated lambda x is equal to 0.8, lambda y is equal to 0.6. So stiffness matrix KAD is equal to AE by L. There is a formula lambda x square, lambda x, lambda y, minus lambda x square, minus lambda x, lambda y, lambda x, lambda y, and lambda y square, minus lambda x, lambda y, minus lambda y square, and minus lambda x square, minus lambda x, lambda y, lambda x square, lambda x, lambda y, and minus lambda x, lambda y, lambda y square, lambda x, lambda y, and lambda y square. Okay. So now this will become, you will get answer C for question number 4. By substituting lambda x, lambda y, we calculated in the earlier problem lambda x, lambda y. You will get the answer option C for question number 4. Now coming to question number 5. It is also determine stiffness matrix. So for question number CD, this is 3 and 4. This is 5 and it is 6. So here lambda x is equal to cos theta x. Lambda y is equal to cos theta y. So that is equal to cos theta x is, that is at point C, it is making an angle 90 degrees. So cos 90 is 0 and cos 0 is 1. Okay. So x-axis making 90 degrees with y-axis. That's why it is theta x is 90. And y-axis is making 0 degrees with y only. So it is 0, 1. So now the matrix will become KDC. If you substitute in the same formula, 0, 0, 0, 0, 0, 1, 0, minus 1, 0, 0, 0, 0, 0, minus 1, 0, 1. Okay, if you substitute this in the same, you will get, okay. And what will be the matrix to multiply with load on joint D and C? These are a very long answer question, but the answer for question number 6 is D. Similarly, for question number 7 answer is A. This is a global stiffness matrix. So very lengthy explanation. And coming to question number 8. So he asked us to calculate what is a displacement matrix and force vector. So generally he has given, this is the diagram. There is a hinged support, there is a roller support, there is again a roller support. So here it is 3 and 4. So it will be 1, it will be 2, so it will be 5, it will be 6, and it will be 7, and it will be 8. Clear? Okay. So now this is A, B, C, and it is D. So now displacement vector is, you can write like, so at 1 there is a reaction in horizontal direction, right? At point A horizontal reaction is there, so there is no horizontal displacement. And in the direction of 2 there is a vertical reaction, there is no displacement in the vertical direction. And at 3 it is not a support, it is a joint. You can have both horizontal and vertical, that is U3 and U4. And at 5 there is no horizontal reaction, there is a horizontal displacement U5. But in the direction of 6 there is a vertical reaction, so there is no displacement, it is 0. At 7 U7 there is a horizontal displacement, and at 8 there is no horizontal. This is a displacement matrix. Okay. And now coming to force matrix. Force matrix, there is a P1 at 1, P2 at 2. There is opposite 3 kilonewton, and here above 3 kilonewton. So because this 3 is in opposite direction, we need to write it as minus. And this top 3 is same as in fourth direction, we need to write it is in 3, positive 3. So 3, 4, and 5 it is displacement is there, so force is not there. And at 6 it is P6, and at 7 displacement is there, it is 0, and at 8 P8. So this is a force matrix, and the answer for this is option A. You can observe it. Okay. And for question number 9, it is also a long answer. We need to solve many steps. It is 9A is the answer, and 10 is also A is the answer. Okay. So that is 1.808 kilonewton is member is under compression. Okay. So in this there are long answer questions. Okay. This is all the questions are related to only one diagram. Okay. Thank you.